Hey everyone, Professor Hank here. So today we're going to give you a brief introduction to strings in Java. We're going to talk about how you can create strings. We're going to talk about how you can compare them. We're going to talk about some of the useful operations you can perform with strings. And then we'll also talk about some of the idiosyncrasies of strings in Java along the way. So let's go ahead and get started. So the first thing we'll talk about is how you can actually create a string. And there's a couple different ways we can do this. The first is going to be to use a string literal. And so there's two pieces to this. We're going to need the string data type, and then we're going to need an identifier. So we'll say string S, we'll have an assignment statement, and then we'll put inside of these double quotes a sequence of characters. So that will be like hello. Okay, so this is actually going to create two things in memory, and those things are going to be a reference which stores the memory address of an object that is responsible for that string. In this case, the string being hello. So there's actually two things that get created in memory there. Now, the second way that we can create a string is we can use the new keyword where we're very explicit about it, and we can put inside these parentheses here the string that we want to create. So this is going to create two things in memory as well. So the reference, which we call T, which is going to refer to this object right here, which is responsible for taking care of that world string. And since they're objects, we can do some interesting things with them, which we'll see examples of. Now, let me show you another way that you can create strings. You can take an existing character array, let's say something like name, and we can give that character array to the string object, and it will extract all of the individual characters out of the array, put them together, and make a string. So we'll do something like this: string u equals new string, and then we'll pass it the name of our array. So that will create a string Hank and store it in that object, right? So we actually have three different strings here and three different string objects, and we've got three different string references. Now let's talk about an idiosyncrasy of this. If we were to create another reference, right? Let's say we're thinking we want to have a completely separate variable holding a separate hello string. You might think, well, we can do something like this. We'll say string v equals hello. Well, as it turns out, this is only going to create one thing in memory. And that one thing is the reference v. Now what's going to be assigned to v? It's going to be the memory address of the first string object. So even though we have two separate string literals here, since they're exactly the same, Java, to be more efficient, is not going to create a second hello object. It's instead going to just take the memory address of this hello object and put it in V. So both S and V are going to be referring to the same object. And so we can see that by using equals. And this will be the first way that we can kind of do comparisons between strings. But keep in mind that we're comparing, this compares the memory addresses, or what's being pointed at or what's being referred at in S and V. It compares the addresses in there in S and V. And so if they're both referring to the same string object, then they're both going to have the same memory address, and therefore equals is going to evaluate to true. So if we say if S equals V, then we can say, oh, well, they're referring to the same thing, right? So we'll do system.out.println. We'll say S and V are pointing or referring to the same thing, okay? And then we will see that when we run this, and we'll see that in the output. Okay, so you can see S and V are pointing, referring to the same thing. Now, if I was to change this to, say, spam, well, that's going to create two things in memory now, because this and this are two separate strings. Therefore, we're going to need two separate objects, one for hello, one for spam. And so now this is going to evaluate to false because they're pointing to two different things, right? They're referring to two different things. So you can see that it doesn't, we don't have that output anymore saying, oh, they're referring to the same thing, because these are two separate objects, okay? All right, now let's look at another way that we can compare strings to each other. We can actually compare them to see if they are exactly the same. So we can do something like S dot equals. In other words, we're going to use the equals method. We're going to ask one of the string objects, hey, are you the same as this other string object over here? So we'll say, hey, S, that string object that you are referring to, is the string in there the same as the string in the object that V is referring to? If so, return true, otherwise return false, right? So we'll just do like something like system.out.println, same strings, else we'll print out, different strings. Okay? So you need to use equals if you want to actually compare the strings against each other. Okay, use that equals method. See, it says different strings. That's because obviously spam and hello are different. So equals is comparing the actual strings. And the relational operator is comparing what the two references are referring to, what the address is. Okay, and then this is actually comparing the strings and returning true or false. Now there's one more way that we can compare the strings, and that's lexicographically. And that is going to be done using the compare to method. And the compare to method will not only tell you whether or not the strings are exactly the same. If they're not the same, it'll give you some additional information. We do compare to, similar to how equals works, we'll ask one of the objects to compare itself to another. So s.compare to, and we'll do v. Now this is going to return one of three types of integers. So we'll just look at that. Okay, so it'll return 0 if the strings are exactly the same. If not, it'll return a negative number if s comes before v lexicographically, and it'll return a positive number if s comes after v lexicographically. Okay, so let's take a look at what that gives us. So s compared to v. So what number do we see? Negative 11. So it's negative 11. Why? Because let's take a look at s, hello. Now let's look at v, spam. Hello comes before spam because H comes before S. So we get a negative number. Now, if we change this to, I don't know, wello, then we'll get a positive number because W comes after S. Okay, so there's that positive number. So lexicographically just means it does a character by character comparison, right? And if they were exactly the same, so let's say that we change this to spam, then it would give us 0 because it does a character by character comparison. And so long as they're the same, you got the same length and all that, then if they're exactly the same, then you're going to get 0. Okay, but if they're not exactly the same, you know, and then we have maybe this is jam, well then that's going to give us a negative number because J comes before the S. Okay, so that's how compare to works. So you can get some additional information that equals just won't give you. Okay, now let's look at some other interesting operations that you can perform on strings. So we can access individual characters, right? So we can do something like this. We can do s.char at, and then we can specify the index number of a character that we want to retrieve. So let's say that we wanted to get the E out. Let's say that we wanted to grab that. Well, then we would specify 1 inside these parentheses as an argument, and that would say, give me the second character out of that. And then we can do with it whatever the heck we want. You know, maybe we just print it out on the screen, right? So we can access it. But what we can't do, and there's the E, what we can't do is we can't change it. Strings are immutable. Okay, so what that means is some of you might be thinking, oh, if you're from a C background or something like that, you might think, well, I want to change that H to something else. So maybe I'm going to say, let's grab the first element and change that to a lowercase h. Not going to work. This is not valid syntax because the string objects are immutable. You can't change them like this. Okay, so what you end up having to do is some extra work, kind of working your way around that. Let's talk a little bit about concatenation. So let's say that I had two different strings here and I wanted to join them together. Well, I could do that by using the plus operator. So I could do something like this. I could say s plus t, and that will do concatenation. That will join the strings together and create a brand new string called hello world. So this is actually going to instantiate a new string object and take the hello and the world, mush them together, and then this new object is going to keep track of or manage that hello world. So I will assign that to another reference and then we'll print it out just so you can see it. System.out.println u. So we'll see hello world and it'll be all one word. There won't be any space in there. Why not? Because there's no white space. I didn't put any in there. If I wanted to put some white space in there, well, then I can do a literal, right? So I could do something like that and see how there's just a space in there. And if I do that, then I'm combining a couple references and I'm combining a literal, which is just an empty string, right? So hello world, but I could also do something like this. Hello, comma, fantastic world or something like that. So in that way, I'm creating a whole new string, which is being referred to by you, right? So you can do all kinds of concatenation like that. Another thing we could do is we could do something like this. We could say s plus equals t. Okay, now this looks kind of weird. Now remember what s plus equals means. It's like this. It's like doing this. S equals s plus t. So what's going to happen is that this s plus t right here is going to create a new string object, and that string object is going to contain hello and world, and then that is going to be assigned to the s variable. Okay, so let's take a look at that. You're going to see that we've got that whole hello world thing going on again. Now, what happened to the hello? The hello is gone because there's no longer a reference referring to the original object holding that original hello string. So this is gone. So it's going to disappear from memory. Java's garbage collector is going to remove it from memory, and we're not going to have access to it anymore. If we wanted to preserve it, then what we could do is we could create another reference, right? And so now here, both U and S refer to hello. And so then once we do this right here, that leaves us with only U referring to hello. But it's going to preserve it, right? Since there is still a reference referring to the original hello, we can still use it. We can still access it. It's still going to be there in memory for us. And so you can see there's the hello, right? So it's kind of a little quirky thing about Java, concatenation and the fact that it's immutable. Now, if you wanted to change that H, for example, then what we could do is use one of the methods that are provided by the objects. We'd have to do a little bit more work. So we could do something like this. We could say string v equals, and then we'll do a little string h, lowercase h, and then we want to grab the rest of the hello from that string. So what we'll do is we'll grab a substring. So we'll do u dot substring, and then we'll specify the beginning index of what we want to grab. So I want the rest of the string. So I want everything after and including the E, right? I want everything after that H. And so that will grab a copy. This will create a new object, a new string object that holds the LO, and then we'll concatenate the LO and the H, which will give us a new string, hello, in a new object, and then we'll assign that new object to V, okay? So that's how we can get around that immutability problem. So we'll print out the V, and then you'll see that we've got our lowercase hello. Okay, so there you go. Okay, now let's say that I only wanted E out. So what I'm going to do is I'm going to specify that starting index again, and I'm going to tell it to go up to, but don't include the index after it, right? So this is kind of like how Python does its string splicing. So let's take a look at that. So now you can see that there's the he right there, right? So we only grabbed the E out, creating a new temporary string object representing a string that has E. Then we concatenated the H and the E together. That made he another object, and then that was assigned to V. And so since there's nothing referring to the H here, and there's nothing referring to that substring E, those both leave memory, and we're left with just he being referred to by V. So look at just a couple of more methods here. There's plenty of these methods to go through, but we'll just look at a couple more here. So another way that we can do concatenation is we can use the concat method. So what I'll do is I'll do s.concat, and then I'll pass the reference of the object that I want to concatenate, or I want to append to the object referred to by s. And so this will return a new object with that concatenation done. Okay, so then we'll do that. Okay, and then I will print that out just to show you that it worked. So that is another way that we can do concatenation. So let's see a little world there. Okay, we can ask a string how long it is. So we can do system.out.println, then we'll do u.length, and that'll return how many characters are in the string. So you can see that we have all these different useful ways of processing strings. So you can see 10 because hello plus world is 10 characters long. Another thing we can do is we can convert a string into all lowercase. So we could do something like this, u.to lowercase. There's also to uppercase too, but to lowercase. Now, remember, strings are immutable. You can't change the original string. So what this is going to do is it's going to take that hello world that U is referring to, and it's going to create a new string object with all lowercase characters and return that. And we could assign that to the same reference or to a different one, right? So if I wanted to replace the original hello world, then I would just say, hey, give me a copy of yourself that's all lowercase, and then replace yourself essentially, right? And then we'll have you point to that new version. And so you'll see that we've got an all lowercase version. And so there's also two uppercase versions of this method as well, but you can see that we're all lowercase now. We can ask a string object to give us a character array version of itself. So we could do something like this. R, and then we'll do u.toChar array. Okay. And then from there we could, maybe do a for each loop and do something like this. We could say for char C R, and then we'll just print out each individual character one at a time, right? Print. And then we'll do C plus a space, just so we can see it all on one line, and we can see the individual characters getting printed out one at a time with white space in between them, right? So there's the hello world, right? So there's all kinds of different behaviors we can employ with strings. And so those are just a few examples. All right, so that's everything that I want to cover with you on strings in this video. So what are some of the things that we looked at? We looked at different ways of creating strings. We looked at different types of operations that you can perform on strings. We looked at some of the idiosyncrasies of strings in Java. As usual, if you're a student of mine, have any questions about any of the topics covered in this video, feel free to stop by my online Zoom office hours or email me through Canvas. Thanks for watching, and we'll see you next time.